Hey everyone, James Murphy here with mCoding. In this video, we're talking about method chaining. This design pattern is not specific to Python, and you may also see it referred to as method cascading or using a Fluent API. Here we have a simple player class. The player has a name, a position, and a level of fatigue. We can draw players, move players, and let them rest. So let's create a player. I make a player James, then move him up, right, up, let him rest, and then draw. There's nothing wrong with doing things this way, and this is how I usually do it. But look how much of this code is just repeating the word James. This is a verb-driven API. Move, rest, and draw all just return none. So how about instead we make them all return self? Then each of these methods returns the James object back to me. So now I can delete these and do this. Now all the repeated information is gone. You can put all the calls on separate lines if you use line continuations. Or if you wrap everything in an extra pair of parens, then you don't need line continuations. And this is the style I see most common in the wild. Just keep in mind that in order to convert an API into this form, all of the methods had to return none. This kind of API works because each of these methods is a verb that mutates the underlying object. And there's also a variant of this pattern for immutable objects. You're probably familiar with the idea even if you haven't explicitly used it. Here I have some random text. Then all chained together, I can say take the text, strip it, uppercase it, and center it. In Python, strings are immutable, so instead of actually stripping the string, it returns a stripped copy of the string. And likewise, the other methods return some kind of modified copy of their self parameter. Here's an example how to code a class with method chaining support using copies. I've got a basic XYZ vector, and normalized returns the same vector but scaled down to unit length. Just compute the length of the vector, then construct a new object of the same type as self. Of course, pass in the modified arguments. And the same kind of thing goes for a reflected vector. Now we can create a vector 1, 2, 3, and I can get a reflected normalized copy. Because we made a copy, our P and Q are different. If reflected and normalized modify the original vector and then return self, then they would be the same. Of course, there's always a penalty if you're making copies of things, but there are also benefits to making things immutable, so this is a trade-off that you get to decide. How about a real and useful example of where this actually shows up? Here I have two SQLAlchemy database models. My user model has an ID, a name, and a full name. And the address model has an ID email address and the user ID that the email address corresponds to. Straight from the docs, look how we can pick out an email address. We start with a select address. This creates a select object. A select object models a select statement that you're going to send to the database to get information back. At any point in the process, we can print the select statement and see the SQL that it corresponds to. So here we have a select ID, email address, user ID from the address table. When I uncomment the join, now I have join text on the end of the query. Every time I apply another method, I get back another select object with a more detailed query. This is method chaining at work, and it makes creating SQL queries really easy in Python. How about a data science example? Here's some sample sales data across 4 different months for 3 different companies. Using plain old pandas, you might write code that looks something like this. First, we create a data frame object from the sales data. We don't really care about company 1, so we delete it. We know there are some nans in there, and for this analysis, we don't want to use them, so we'll drop them. Oh, and these aren't just company 2 and 3, it's actually Amazon and Facebook, so let's rename. And the Google data was stored somewhere else, so let's go ahead and add it in. Then we go ahead and proceed to do whatever data analysis we were going to do. There's nothing necessarily wrong with this code, but it's still kind of just hard to read. Enter Pyjanitor. It's a library that you can pip install, and it provides a method chaining verb-based interface to pandas data frames. Now, the same operations as before can be done in a much cleaner and more uniform way. I hope you can agree that this is a lot easier to read than the previous example. I load my dictionary, I remove a column, I drop the nans, I rename a column, I rename another, and then I add a column. And that's all there is to it. It's all the same functions as before, or you can define your own, and it just provides an easy way to kind of create a pipeline for your data. If you're an R programmer, then this should look pretty familiar to you, and the design of this library was actually inspired by R. Remember, don't ever try to force this into one of your projects, but do consider it as an option. That's all I've got. Please let me know, what do you think? Do you like the way that method chaining looks? Is it more or less readable? Are copies worth it for immutability? Or would you just prefer to avoid it? Let me know with a comment. As always, thank you to my patrons and donors for supporting me. If you especially enjoy my videos, please consider becoming a patron on Patreon. Enjoy your day coding, and don't forget to slap that like button an odd number of times. See you next time.